So if you look at a $15 smart plug on Amazon, right? And then you look at like a $400 smart lock, it is incredibly easy to think they just belong to completely different universes.
Oh, absolutely. I mean, one looks like a disposable plastic toy and the other feels like, military-grade hardware.
Yeah, exactly. The price tags definitely tell two very different stories about what you're buying and the expectations you should have when you take them out of the box.
Right.
But when you strip away the marketing and you look at what's genuinely driving the smart home forward this week, the core tension inside both of those devices is identical.
Yeah, it really is.
It all comes down to this just brutal tug of war between reliability and cost. So welcome to this week's episode of Smart Home News. Let's jump right into our deep dive.
We're going to examine the microscopic circuit board decisions happening inside those budget devices, all the way up to a premium lock that just throws out the mechanical key entirely in favor of invisible radar.
Which is wild. Yeah. But our mission for this episode is really to cut through the short-term gadget hype, and focus on durable smart home ideas.
Right, because there's a lot of noise out there.
There's so much noise. So we're looking at major strides in local control, the physical realities of hardware engineering, and what you are actually sacrificing when you buy heavily discounted entry-level gear.
Yeah, and whether you're an experienced automator with a full rack of servers in your basement,
right,
or you're just starting out with a couple of smart bulbs, this weekly report is designed to help you build a serious, reliable home infrastructure.
Exactly. Because a smart home is really only as good as its foundation.
Right. And for a lot of people, we're seeing that foundation shift aggressively away from cloud dependency.
Yes, which leads us straight into our first major development of the week, IO Torero.
Ah, yeah. Formerly Atham Technology, for those who remember.
Right. They've officially joined the Works with Home Assistant program. And they're providing the very first ES Home-ready smart plugs and relays to the program.
Which is huge.
It is. Now, I know ES Home is a massive deal for local control, but for anyone who hasn't tinkered with it, what makes this firmware so special?
So ES Home is an open source system that basically lets your smart devices operate entirely using their internal microchips.
Okay.
With zero reliance on external servers. Historically, if you bought a cheap Wi-Fi smart plug, you were pretty much forced to route your commands through the manufacturer's proprietary cloud.
Right, the whole round trip thing.
Exactly. You'd tap a button on your phone, that signal would travel to a server, halfway across the country, and then bounce back to the plug in your living room.
And if that company pivots or goes bankrupt,
they shut down the servers, and your device is just a plastic brick.
Yeah.
But ES Home eliminates that round trip entirely. The processing happens locally on your own network.
Okay, and IO Torero's new devices like their ESP32C3 plugs and the power monitoring mini relays, they come pre-flashed with this firmware.
Right out of the box.
So how much of a hurdle was that flashing process before they standardized this?
Oh, man, it was a massive barrier to entry. I mean, in the past, getting ES Home onto a cheap device often meant literally prying the plastic casing open with a screwdriver.
Yikes.
Yeah. And then you'd have to solder these tiny wires to the serial pins on the circuit board, hook it up to a computer, and compile YAML code just to overwrite the factory software.
That sounds terrifying for the average person.
It was highly technical, and you carried a very real risk of destroying the device. So by standardizing pre-flashed hardware, Home Assistant is really putting local control within everyone's reach. You literally just plug the IO Torero device into the wall, and your system automatically discovers it.
That's incredible. It sounds kind of like buying a laptop with a complex, highly secure Linux operating system already perfectly installed for you.
Yeah, that's a great way to put it.
You get all the power and freedom of open source software, but you completely bypass that intimidating command line setup. Plus, ES Home just updated to a Visual Device Builder user interface. So they're moving away from that old code editor interface to a visual workspace that actually suggests components and layouts as you build.
Which is great. Lowering that software barrier is crucial. But there's actually a hardware feature inside these IO Torero plugs that fundamentally changes how a smart home operates.
Oh, the Bluetooth proxy.
Yes, they act as Bluetooth proxies.
I saw that in the release notes. But how does a Wi-Fi smart plug help with Bluetooth devices?
Okay, so think about small battery-powered sensors, like a Bluetooth temperature sensor in your freezer, or maybe a soil moisture sensor out in your garden.
Right.
Bluetooth Low Energy is amazing for battery life, but it has terrible range. It usually can't reach your main smart home hub.
Yeah, it trucks off constantly.
Right. So a Bluetooth proxy solves this. The IO Torero plug essentially sits halfway between the sensor and your hub.
Oh.
It uses its internal antenna to intercept those tiny Bluetooth broadcasts from the sensor, packages that data up, and then tunnels it over your strong Wi-Fi network directly to Home Assistant.
Wow. So it's basically acting as like a bilingual translator and a megaphone combined.
Exactly.
It hears the weak Bluetooth signal and just shouts it over Wi-Fi to the central hub.
That is a perfect analogy. And honestly, this is brilliant infrastructure design. You're taking an everyday appliance, a plug that's already monitoring your energy usage, and you're turning it into an organic network extension.
So you don't have to go out and buy a dedicated single-purpose repeater hub just for your Bluetooth stuff.
Right, which is a direct reduction in electronic waste. And it guarantees that your automations survive even if your internet service provider goes down.
Which we all know happens way too often.
Yeah, unfortunately.
So IO Torero proves we can fix the software side of cheap hardware. But physically, like inside the plastic casing, how are manufacturers actually building a $15 relay that doesn't just melt or drop offline when it's stuffed into a crowded electrical box in your wall?
Yeah, well, we got a fascinating look at exactly how that happens this week. Eric Reichard at the Z-Wave Alliance just published part 6 of his Z-Wave developer's journey.
Oh, I read that.
It's essentially a masterclass in the ruthless physical optimization required to build cost-sensitive wireless devices.
Because space is the ultimate constraint here, right? These printed circuit boards, the PCBs, they're typically just a few square inches.
Exactly.
Yeah.
You are designing for a highly restricted physical footprint while still trying to maintain pristine wireless performance. And Reichard points out that one of the biggest decisions a manufacturer faces is whether to use a 2-layer or a 4-layer PCB.
I mean, why not just use a 4-layer board every time? Does the manufacturing cost really jump that much for just 2 extra layers of fiberglass and copper?
It really does. A 4-layer board costs about 40% more just for the bare circuit board itself.
Wow, 40%.
Yeah, but it provides significantly better RF impedance.
Okay, let's break down RF impedance for the listener, just so we're all on the same page.
Yeah.
How does that translate to the actual experience of using the smart plug in your house?
So RF impedance is basically about how smoothly the radio frequency signal travels from the microchip to the antenna.
Okay.
If the impedance is mismatched, the signal actually reflects back on itself, creating interference.
Oh, I see.
Yeah. So your wireless range drops and the device falls off the network. Now, on a 4-layer board, engineers can dedicate an entire internal layer strictly as a ground plane.
Right.
And that ground plane acts as the other half of the antenna, stabilizing the signal perfectly.
Right.
But to keep that $15 price tag, engineers usually have to stick to a 2-layer board.
Which means they lose that dedicated internal layer entirely.
Exactly.
So how do they prevent interference if they're forced to cram everything onto just 2 layers?
They have to use a technique called continuous ground fills. Instead of running tiny copper wires to connect all the ground points, they flood basically all the empty space on the board with solid copper.
Interesting.
Yeah. It acts like a giant sponge that absorbs electrical noise. And they also try to keep all the surface mount components on just one side of the board, because if you run the board through the factory soldering oven twice, it literally doubles the assembly cost.
Right. Wow. That feels like trying to pack a suitcase perfectly, but with a rule that your wet shampoo bottles like. The power circuits cannot be anywhere near your clean silk shirts, which are the delicate wireless antennas.
That's a great way to think about it.
And on a 2-layer board, you don't have those separate zippered compartments to keep them apart.
No, you don't. That is the real challenge of the craft. And they even have to optimize the factory testing process. Reichard mentions that instead of building expensive, fragile, custom testing jigs with pogo pins to program the chips on the assembly line.
Which sounds pricey.
Very. So instead, they design standard Tag Connect footprints directly onto the board. They're these tiny standardized contact points that a universal programming cable can just snap right into, often hidden right under the battery door.
Okay, let me push back on this whole manufacturing approach for a second.
Yeah.
If companies are minimizing layers and just flooding empty space with copper to make do and squeezing all the components onto one side just to save literal pennies in the soldering oven,
Yeah.
are we just buying fragile e-waste? I mean, are these budget devices inherently destined to fail because the budget is just so tight?
It is a totally valid concern, but I look at it a bit differently. This isn't necessarily about cutting corners. It's about brilliant engineering trade-offs.
Okay.
Routing wireless traces without interference on a tiny 2-layer board takes years of expertise. I mean, you can build a terrible two-layer board that drops off your network constantly, or you can build a brilliantly engineered one that performs flawlessly. This is exactly why certification programs matter so much. When UCO works with Home Assistant Badge or a Z-Wave certified badge, it's proof that the hardware was engineered correctly despite those strict budget constraints.
Yeah, that's the art of constraints, right? Making a budget device perform reliably. But what happens when an engineering team has absolutely no budget constraints?
Oh, then things get really interesting.
Right, like what happens when you throw premium expensive hardware at a problem to guarantee absolute reliability?
Then you get a product like the newly announced Schlage Sense Pro Smart Lock.
Yes, Schlage just announced this lock, and it comes in at a whopping $399.
It's not cheap.
No, but the technology inside is incredible. It is their first lock with ultra-wideband, or UWB, auto unlock. It's their first Matter over Thread lock.
Yep.
It works with Apple HomeKey, with Google and Samsung support coming soon. But the most striking detail to me, it has absolutely no physical keyhole.
None at all. They are entirely removing the mechanical failsafe. It's really the ultimate test of trust in a wireless protocol.
I have to pause on that decision because a smart lock with no physical backup just seems incredibly risky.
Oh, for sure.
Is ultra-wideband really that much more reliable than the Bluetooth or Wi-Fi geofencing we've used for years? Because, I mean, we've all stood on our porches in the freezing cold waiting for our current smart locks to realize we're actually home.
We all have. But the technical leap from standard geofencing to UWB is massive. Standard geofencing relies on your phone's GPS and the operating system's background tasks.
Okay.
And because your phone is constantly trying to conserve battery life, it only checks your GPS location every few minutes.
Right, which causes the delay.
Exactly. By the time it actually realizes you're standing on your porch, you've already been waiting there. It's slow and it's imprecise.
So how does ultra-wideband fix that specific delay?
Ultra-wideband acts more like a highly precise localized radar system. Instead of relying on general GPS coordinates, the lock and your phone are sending billions of radio pulses back and forth every single second.
Billions. What?
Yeah, and they measure the exact time of flight, which is literally how long it takes the radio wave to travel through the air between the two devices.
That's amazing.
And because radio waves travel at the speed of light, the lock can calculate exactly how far away you are down to the centimeter in real time.
Wow.
It knows your trajectory. It knows if you're walking toward the door or walking away from it.
So as I walk up the driveway, the radar tracks my approach and triggers the motor right as my hand reaches for the handle. No tapping a watch, no fumbling for an app.
Exactly. It enables a truly reliable, hands-free unlock experience. And it pairs that with Matter over Thread for its broader smart home connection.
Let's define Thread for the listener real quick, because that's another layer of reliability here.
Sure. So Thread is a low-power, wireless mesh networking protocol specifically designed for smart homes.
Right.
Unlike Wi-Fi, where every single device has to connect back to a single central router, Thread devices talk directly to each other.
Right, it's a mesh.
Exactly. If one device in the mesh loses power, the data simply routes around it through another device. It's a self-healing network that operates completely independent of your main Wi-Fi router.
Okay, but even with UWB radar and a self-healing Thread mesh, abandoning a mechanical backup is just a huge leap of faith to me.
It is.
Like, what happens if the motor simply dies? Or what happens if there's a mechanical jam inside the deadbolt mechanism itself?
Yeah.
UWB might send the signal flawlessly, but physical gears can still break. You are entirely dependent on the electronic ecosystem functioning perfectly.
You are. It is a fundamental shift in how we secure our homes. You're essentially prioritizing seamless, invisible convenience over fail-safe redundancy.
Yeah.
And you're paying $400 for the privilege of trusting their engineering team. For some people, that level of precision is absolutely worth the price, but it undeniably carries a real physical risk of being locked out of your own house.
Paying for absolute precision makes total sense for your front door, right? But for the rest of the house, you're probably looking for deals. And right now, the market is aggressively discounting entry-level ecosystem gear. But you really need to understand what you're sacrificing for those discounts.
Yeah, we're tracking 2 major sales right now that highlight the trade-offs of budget hardware perfectly.
What are they?
The Philips Hue Essential Starter Kit, which includes 4 color bulbs and a Hue bridge, has hit an all-time low of $80.
Wow.
And the 2020 Google Nest thermostat is also down to its best price of the year at $79.
Okay, on paper, both of those deals look fantastic. They both offer Matter compatibility, which means they'll integrate into almost any smart home platform you have.
Right.
But you have to read the spec sheets carefully. Let's look at the Hue kit first. You get 800 lumens and tunable white in color. However, these are the budget essential bulbs.
Right, there's a catch.
The main sacrifice here is that they only dim down to 2%, whereas the flagship Hue bulbs dim all the way down to 0.2%. Plus, Philips Hue does not guarantee cross-generation color accuracy on these budget models.
And, that dimming limitation has a surprising real-world impact due to just how our eyes work. Human perception of light is logarithmic.
You mean what exactly?
Meaning when you're in a pitch-black room, your pupils dilate, and a bulb running at 2% physical brightness actually looks incredibly bright.
Oh, I see. So a bulb that only dims at 2% is completely fine for a hallway, a closet, or a kitchen.
Sure.
But it is going to ruin the experience in a dedicated home theater or a bedroom where you want ultra-low moody lighting.
Exactly the issue. And we see very similar trade-offs with that $79 Nest thermostat.
Right.
It gives you remote app control and HVAC monitoring, sure, but because it's the 2020 entry-level model, it completely lacks the AI schedule learning of the flagship version.
Okay.
And more importantly, it does not support remote room temperature sensors.
Meaning it only knows the temperature in the exact hallway where it is physically mounted on the wall.
Right. If you live in a small single-zone apartment, that limitation really doesn't matter. But if you live in a multi-story house with distinct hot and cold spots, a thermostat without remote sensors is a terrible infrastructure choice.
Yeah.
Your upstairs bedroom might be sweltering, but the system won't run the AC because the hallway downstairs feels perfectly comfortable to the thermostat.
It is so easy to get caught up in a sale and end up with a device that just doesn't fit the physical realities of your home.
Oh, it happens all the time.
And, if you're trying to figure out which devices actually fit your setup, smarthomecompared.com can help you compare smart home products by ecosystem, features, compatibility, and integrations before you buy.
Yeah, checking those technical requirements, like checking for remote sensor support that saves you from buying the wrong infrastructure and putting holes in your drywall for literally no reason.
Exactly. Doing the research up front and understanding the compromises of budget hardware is the only way to build a system you won't want to rip out 6 months later.
Right.
So checking those requirements saves you from buying the wrong infrastructure. But sometimes the biggest threat to your smart home isn't the wrong infrastructure. It's buying something that isn't infrastructure at all.
Yes. We actually have a story this week that perfectly illustrates the distraction of shiny gadget syndrome.
Oh, the sourdough thing.
Yeah. King Arthur Baking Company has co-developed a new gadget called the Sourdough Sidekick.
Okay.
It is a dedicated countertop device that automatically feeds your sourdough starter flour and water on a set schedule.
I mean, baking sourdough is inherently about natural fermentation, right?
Right.
It's about patience, feeling the dough, and adapting to the humidity and temperature of your specific kitchen environment.
Yeah.
It is the most analog, old-fashioned process imaginable.
Exactly. And now we're inserting a scheduled robotic cloud-connected dispenser into it.
This is officially our gadget hype alert for the week. It is a single-purpose device that lives in its own silo. It does not integrate into a broader smart home ecosystem at all. Yep. You cannot trigger it with a routine that says, when I arrive home, start feeding the sourdough.
Nope.
It solves a hyper-niche problem by isolating itself from the rest of your home entirely.
And when we look at the life cycle of products like this, they almost always end up in a landfill.
Yeah, the novelty wears off.
Right, or you just stop baking sourdough for a month and it just becomes clutter, taking up precious counter space. It fails the infrastructure test completely.
So our advice is, take the money you would spend on a novelty dispenser and invest it in durable home infrastructure.
Yes.
Buy better Wi-Fi access points. Buy Thread border routers. Invest in robust local hubs like we talked about with Home Assistant earlier.
Right.
Build a strong, resilient network first, rather than buying isolated appliances that cannot talk to anything else.
Because building a reliable smart home is a serious craft.
It really is.
Whether you're leveraging open source, pre-flash ES Home hardware to ensure your automations survive an internet outage, or you're relying on engineers routing two-layer PCBs to keep costs down without sacrificing wireless impedance, the goal is always long-term reliability over short-term flash.
Definitely. Even when you're navigating the feature compromises of a budget thermostat or trusting ultra-wideband radar to unlock your front door without a key, you want a home that responds to you consistently and securely.
Absolutely.
As we wrap up this deep dive, I want to leave you with a final thought to ponder. We talked about how Schlage is using UWB radar to detect your exact distance from the door down to the centimeter, right?
Right.
Well, as technologies like UWB and Matter over Thread become standard inside our basic appliances, our TVs, our smart speakers, our thermostats, will our homes eventually be able to map our exact locations down to the inch as we walk from room to room without using a single camera or motion sensor?
Wow.
And if our homes can build a real-time radar map of everywhere we walk, who really owns that spatial data?
That is a massive question, and it's one the smart home industry is going to have to answer very soon.
They really will. Well, thank you so much for joining us for this week's episode of Smart Home News. If you found this episode useful, please take a second to rate the podcast and leave a comment on Spotify or Apple Podcasts. It genuinely helps us continue bringing you these weekly reports. We will see you next week.